Feisty Fidget Coders, it's Professor Gallagher, and in this lesson we'll review the solution to the Fidget Dot challenge presented at the end of part 2 of Bring On to Func, our second lesson on functions in CircuitPython. If you need a review of that challenge, here it is. You can pause and check it out, or if you want to hear me explain and see a longer demo, you can visit the end of the prior lesson. But for those of you who are ready, let's plug in our CircuitPlayground boards, launch PyCharm, and make a little awesome. And for those of you who are new to the course, you can check out the playlist to see how we got to this point. Now, the code that was loaded at the end of the lesson was our play sound code, which is good because we're going to play the splat sound as part of the solution. Hopefully you had this up when you started, and if you struggled and you're going to follow along with what I'm coding here, you can load up a fresh version of play sound before we start. Now, the challenge did give you a hint to use debounced buttons, so let's import the debouncer library. Right underneath where we import our colors, we'll say from Adafruit_debouncer, import capital B button. Now we have two standard buttons set up. Let's convert these to debounced buttons. So I'm going to change the name of the first button from button_A to button_A input. I'll copy and paste that down on the second line as well. And I'm doing that because I want to create a debounce button named button A, and we'll set button A equal to capital B button, that class we just imported. And in between the parentheses, we pass in button A input, our standard button. And just a quick aside, as is sometimes the case, the first solution I posted on this had something I wanted to correct. So the video you're watching was actually posted one day after the initial release. I had initially forgot to add the second parameter in here, comma, value_when_pressed equals capital T true. Now by eliminating that, it assumed value when pressed was false, and the code still worked, but the effect was that the button press didn't fire until the finger was pulled off in the released position. I thought I'd mention that, not only for the people that watched the video on the very first day when it came out, but also to point out what this second parameter actually does and why it can be important. Then we'll do the exact same thing down below for button B, so we'll call these first two lines button B input, and then we'll create a button B on the third line, setting it equal to capital B button, passing it again, button_B_input. And don't forget comma, value when pressed equals true. Now, when we use debounced buttons, we have to constantly get their current state using the update method. So inside while true, as the first two lines will say, button_A.update with two parens, button_B.update with two parens. Now, our if statements check the buttons.value parameter, but that's only good for standard buttons. We have debounced buttons. We're going to check to see what happens with a press. So we're going to put .pressed where .value is. And now the challenge actually says to create a move_dot function, and it gives you the three parameters to pass in. So we'll do that above while true. We'll say def space move_dot, and in between the parentheses, the three parameters we have are position, that'll be the light location from 0 to 9, comma, direction, it'll either be 1, we move forward 1, or -1, we move back 1 if you press button B, and comma, color is the last value. It'll be red for button A, blue for button B. Never forget your colon at the end of the function definition line. The challenge asked you to play the splat.wave sound every time a button was pressed, so the first line we'll have in here is play_sound, passing in the string splat.wave. Then before we turn on the light in the new position, we should turn off the light in the current position. So we'll say pixels, square brackets, position, equals all caps black. Now we get this position inside of our function from a global variable that we pass in called light_position. So why don't we create that up top right underneath our path. We'll say light_position equals, and I'll initially set this to 0, but I'll show you we actually want to update this to a different number. Leaving a 0 in here would cause a problem when we first press a button. I'll show you this, and then I'll show you how we can fix it to light 0 if you press button A, or 9 if you press button B as your first button. And now that we've got our light position variable, let's use that as we call the function. So down in the if_button.pressed, we'll delete what's in there and we'll add a new line, light_position equals move_dot. So that's our function that we just created, and we'll pass in three values, light_position, comma, the direction will be 1. So if you press button A, we'll move 1 forward. We'll add 1 to our current position value, comma, and red will be the color that we pass in. And down below in the button B if statement, we'll add light_position equals move_dot. We're still passing in light position, comma, but this time we're passing in -1 is the direction. We want to move in the other direction, and comma, blue is our color. So now let's finish up the move.dot function. So inside we can say position equals position plus direction, which could be either 1 or -1. And then imagine we keep pressing button A. So we're updating our light position inside here from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now we don't want to go past 9 because if we do, we're going to get index out of range. So down below we're going to say if position greater than 9, colon, then indented below we'll just say position equals 0. So if we get all the way around to position number 9, we're going to go to position 0. Now remember, we can also go in the other direction. So let's imagine, for example, that you're at 4, and then you press button B. You go to 3, 2, 1, 0, and you don't want to go anything below 0. So we'll say in here, elif position less than 0, colon, and if we go past 0, we want to go to position 9. So we'll say position equals 9. Then outdented down below here, we'll say pixels and in brackets position equals color. So we set the position properly above, and now we turn on the pixel with the appropriate color. Then, since we updated the position, we want to return position, and remember, when we return that value, it's going to update the light position. Now let's open the terminal. I'm already in TO. Head up top and save. Now, I'd mentioned there'd be a problem when we start, so watch what happens when I press button A. And look, we're starting not at pixel 0, but at pixel 1. In fact, you can see it more clearly if I press button B, it turns blue, and this is pixel 0. This is where I said that we were going to run into a problem with the way that I had initialized our initial light position value. Let me fix this and tell you what's going on. Now, if I set the initial start position, which is light underscore position, not at 0, but at -1, that's a non-existent light position. But watch the result. When the code first starts, I'm either going to press A and move forward 1, or I'm going to press B and I'm going to go backward 1. If I move forward 1, I want to go to 0. If I move backward 1, I want to go to 9. So let's look what happens inside the function. If we're -1 the first time we go through and we press A, then that passes in 1 is the direction. We add -1, which is the position we passed in, to 1, which gives us our first pixel at 0. We light it up in red. That's what we want to do. Now, what happens if the first button press is button B? Well, again, we pass in -1 as our position, and then we add a -1 to it. So that's like subtracting 1. That gives us a -2. But since that's less than 0, the elif statement down here will set the position to 9. We'll turn it blue, which is exactly what we want to do if we press B as our first button. So that's a bit of a hack, but it works. And you definitely want to think through all possibilities as you code and you test things out. So the first time we go through is that unusual case, but initializing light underscore position to -1 before we hit while true solves our problem. So let's save and try this out. So here we go. Let's press button A, and hey, we see light 0 lighting up in red. Nice. And press A to go forward. That's working perfectly. And if we press B, we can see we go back through 0 to 9. Nice. Now I'll press restart to restart the code, and if I press B, we should see blue in light 9. And there we go. So mission accomplished. Hopefully you got this right, but if you didn't, make sure you rewatch the video and you understand how things work. And if you have some concepts that are still fuzzy, remember you can always go back and you should rewatch the lessons until you really understand the concepts. Now I'm going to change the comment up top to Fidget Dot, and I'm going to save as to my CircuitPython folder with that as the name. Close the extra tab so we're back at code.py. Keep hacking, there's more big learning along the way, and always make something awesome.